everyone. Welcome back to my YouTube channel Azaz Guitar. So yesterday or in the previous video we discussed the theoretical part on electricity chapter. Like we started with electricity, we explained about the charges, like two type of charges, positive and negative. We learned about static electricity. Static electricity, we have done a many experiment when we were kids, like we used to rub the scale, still we are doing it. When we used to rub the scale on our dry hairs, and we used to take near that take that scale near to the pieces of paper, and the pieces of paper were getting attracted. Okay, and like balloon example. So we discussed even about the electric current, like flow of charge in unit time, in unit area, then unit ampere coulomb per second. Potential difference we learned. Without potential difference, then you cannot make the electrons to flow from one point to another point, so there should be a potential difference. Potential difference is set up by the cell or a battery. So batteries, without battery there is no current, right? So let us discuss now our numericals on that. The question is on the screen. Try this sum. The filament of electric bulb draws a 0.2 ampere current. So this is I is equal to 0.2 ampere. It is used for 5 hours. So time is equal to 5 hours. And this 5 hours is nothing but we need to convert into a seconds, remember. So 5 into 1 hour matlab 60 minute. Each minute have a 60 second. So what we should find is that calculate the amount of charge flowing through the circuit. We should find out Q is equal to question mark. So you know the formula, I is equal to Q divided by T. Am I right? So you need to find out Q, so that you will get, if you cross multiply, you will get Q is equal to I into T. So that I is nothing but 0.2, we can write as 2 by 10, and time is 5 into 60 into 60. So here you can cancel this 0 and this 0, and rest all you should multiply. 6 6 are 36, 36 into 10, right? This is 36 and this is 1 0 because of this, and this 10 another 0. So what is the answer? 3600 coulomb. Any doubts? Anyone having any doubts? Okay, so shall we go to the next question? Yes, we have already. So this question. In a particular television tube, a beam of electron is emitted. Okay, a television tube beam of electron is emitted. The beam of current is 80 microampere. So I is equal to 80. Micro is nothing but 10 power minus 6 ampere. How many electrons strike the screen of TV in every second? How many electrons? So N is equal to question mark. And you know that E is equal to 1.6 into 10 power minus 19 coulomb. It is a standard. So whenever N is there to find, this E will come only. And they are asked how many electrons, so N we have to find. You know the formula. You know what is the formula? I is equal to flow of charge in unit time. So I is equal to Q, you can write as NE divided by T. As you want to find out E, so this you can cross multiply. So this E will come here. So the formula will become N is equal to I into T divided by what? E. Yes. So now you will get N is equal to I is 80 into 10 power minus 6. And time they have given, right, 1 second. So right, each second. E is 1.6 into 10 power minus 19. So you will get here N is equal to 80 into 10 power minus 6 into 10 power positive 19 divided by 1.6. N is equal to 80, and 10 power 19 minus 6 will become 13 divided by 1.6. So now what I will do, I will just multiply with the 10. Okay, here with the 10 and here with the 10. So here you will get 800 divided by 16. This 10 power 13. Okay. So if you divide it, then 16 5s are 5 into 10 power 13. So if I 50 10 power 13, or even I can write that 16 ones are 16. Okay, even I can write that 5 into 10 power 14. Am I right? 5 into 10 power 14 is the answer. Correct, everybody? Yeah. And the next is that find the total charge striking the screen in 2 minutes. So total charge nothing but we have to find Q. Correct or no? Total charge striking the screen in 2 minutes. So total charge Q is equal to I into T. So they gave the current 80 into 10 power minus 6. In 2 minutes matlab 2 into 60. So this will become 160. Yeah, 82s are right. So we will have to multiply. Still 8 2s are 16, 16 6 are 96. 96, 8 2s are 16, yeah, 00 into 10 power minus 6. So you can write as how many charges, that is 9600 microcoulomb. Understood? So these are the two numericals based on formula I and based on the formula the total charge Q. Now we'll discuss the next our topic, that is Ohm's law. See, in the previous video you learned that, see, if I have a here bulb and if it is a wire, even you think it switch is there here, plug key, and if I switch on, then whether this bulb will glow, your answer will be no. Correct? Sir, how it will glow without a cell or a battery? So we need to connect it cell or a battery. So if you connect a cell or a battery, that will make the electron to flow in a particular direction. Electrons flow from negative terminal of a battery to positive terminal. If electrons are flowing from negative terminal to positive terminal, so this will be the direction of current from positive. So this electron carrying the energy, and this energy will be given to bulb, so bulb will glow. Okay, right. You know that, like for example, I have a one torch here, and in this torch, I placed a cell. Like the cells are there. Like similarly, another cell is there. In this torch, two cells are there. Correct. So this torch I am using regularly. After few days, I see that the brightness has been decreased. And if I say to you like why the brightness decreased, then you will say that, sir, the cell got weaker. So what exactly meaning of the cell got weaker? The meaning of cell got weaker, whatever the chemical reactions are taking place, so that chemical reactions, like the chemicals are exhausted. Correct na? Because of the chemical reaction, the chemicals are used. So these chemicals are getting exhausted. So when these chemicals are getting exhausted, then the potential difference is getting reduced. So when the potential difference will get reduced, then automatically the current flow will be decreased. Correct? If current flow will be decreased, then obviously the brightness of light will decrease. So from this experiment, we learned that the current is depend on potential difference. If you don't create potential difference is not there, then current is not there. But when you create the low potential difference, then the flow of current is less, so brightness of bulb is less. So we can say this Ohm's law was given by Mr. George Simon Ohm. It was given by this Mr. And it states that current flow, I mean, yeah, you can start with potential difference. Potential difference across the end of a conductor. Potential difference across the ends of a conductor is directly proportional to, yes, it is directly proportional to current flowing through it. Current flowing through it. You can copy. Provided temperature, provided temperature and other physical conditions remains same or constant. Okay. So according to this statement, I can say the potential difference is directly proportional to current flowing through it. So potential difference increase, current will increase, brightness will increase, right? So if you remove this proportionality, then we'll get a constant. This is denoted by R. The formula of Ohm's law is V is equal to IRR RI. R is called proportionality constant. R is proportionality. It is there to all the material. Proportionality constant. It is known as resistance. Every material have resistance. Different material have different resistance. Okay, so now what is exactly meaning of resistance? Resistance means what? See, it is the property of a material. It is the property of a material. What it does, it resists the flow of charge. Okay, so resistance matlab like any conductor you take, they have a certain resistance. Matlab they don't allow the charges to flow so fluently. Just one example you can consider, like one wire is there, one material which is very smooth, so the things can flow very easily. But one rough wire type or rough surface is there, things having a lot of friction or lot of difficulties to flow from one point to another point. So this is, you can consider that electrons are trying to move here, so they are moving with a difficulty. That is nothing but a resistance. Okay, all materials have certain amount of resistance, so they don't allow that electrons or charges to flow so swiftly, right? So now what is the unit of this resistance? Unit of this resistance is ohm. It is denoted by omega, right? Omega it is called. Now what is the Ohm's law formula? We have V is equal to IR, you can say, or RI. From this we can make R is equal to resistance is equal to V by I, or even you can make I is equal to V by R. You can say a magic triangle. Here if you write V, here I, and here R. For example, if you want to find out V, then you can just multiply this both IR, correct? And if you want to find out I, then you can write V, and this is by divided by R. So R, that is I, is equal to V divided by R. Okay. So this is called magic triangle. Like if you want R, then you close this R and you see that in the numerator V is there and denominator I is there. V by I will come, right? So this is Ohm's law and definition of resistance. Resistance is different for different material. Yeah, there are certain factors affecting resistance. Factors affecting resistance. See, there are four factors, I think. Like first is temperature. So resistance is directly proportional to temperature. More the temperature, more the resistance, because the electrons will get extra energy, and when they get extra energy, the collision between the electrons increases. So this is This in turn increases the resistance. So when temperature increases, electrons get more energy, they move randomly here and there, very fast, tend to move very fast. During that, the collision increases. So this is temperature. Second one is area of cross section. Area of cross section of conductor. Area of cross section of material. So resistance is inversely proportional to area. It means that more the area, less the resistance. In simple way, if thicker is the wire, resistance is less. Thinner is the wire, resistance is more. And thicker is the wire, resistance is less. In thicker wire, the area or the space is more, electrons can move very freely. But in thin wire, the electrons have little resistance, or difficult to move from one point to another point due to less area or less space, you can say. Third point. What is the third point? Anyone knows? Yeah, obviously there will be a nature of material. Yeah. So nature of material is what? A different material have different resistance. Like the conductor have low resistance, correct? Conductor have low resistance and insulators have high resistance, correct? Insulator have high resistance. But in conductors also, like copper is having resistance, very low resistance. I think silver is having low resistance, but we are not using it in our wire because of costly. It is very costly. And very important point, length of a conductor. Length of a conductor. So resistance is again directly proportional to length of a conductor. More the length, more the resistance. Obviously, if the length of the conductor increases, then the electron has to travel a long distance. Because the electron has to travel a long distance, obviously the resistance will increase. So these are the factors which affect the resistance of a material. Right. So just see once and I will check which topic is the next to take or to cover. Yeah, there are some like some numericals are there. Once you just go through it, everything good conductor. Okay. Hmm. Yeah, just one topic is connected with resistance. Rheostat. This rheostat is also called variable resistance, and it is a device. What is rheostat? It is a device which is which is used to which is used to what it is used to which is used to change the current, which is used to change the current without changing changing potential difference across the ends of a conductor. See, one device is it is used to change the current. See, we can change the current. Normally current is dependent on potential difference, but here they are telling that rheostat can change the current and without changing potential difference. So how it can do? By changing resistance. You know that example this we are using in fan regulator, or wherever the fans are there, a wall fan or any, like even you have seen in coolers also, like cooler, where there will be a knob to increase or decrease the speed. So how they increase or decrease the speed? So they increase or decrease the speed by what? Changing resistance. Rheostat is used. If you want to increase the speed, then resistance will be less, so more current. If you want to decrease the speed, then less current will go because of resistance will increase. So the rheostat is used in that. Hope it is clear to you all. Understood? So this session I am ending here. In next session I will come with the numericals.